Hello and welcome to the recording on forecasting with time series. This is going to be recording one of a number of recordings that I'm going to use to cover this very important topic. Important to have the latest version of the operating system on your laptop, regardless if it is a Mac or if it is Windows. Okay, so for Windows, it is highly recommended to be in Windows 10. Also, regardless if you have Windows or a Mac, it's important to have installed Office 365, and the version of Excel there should be Excel 2016. And that's going to make a big difference in terms of being able to do everything properly. Forecasting is basically data mining with the x-axis when you're in two-dimensional space, with the x-axis being of a temporal data type, meaning the x-axis has a date, time, things like month. So the x-axis is time, so you can have month or quarter or week, days, time in the day. And so that's the general idea. And the way that I will approach this is I'm going to talk about the concepts one by one, because everything is extremely well intertwined, and and then demonstrate the concepts via examples. If you see, these are PowerPoint slides that basically I copied here from the Evans book, Business Analytics. And the slides are from the second edition, even though the latest edition of the book is the third edition right now, but there's not really that much difference. So if you see this egg type of a figure, it means that if you click on this, it will take you to another spreadsheet to do further analysis. So a time series is basically when you have historical data, such as what you see on this slide right here, meaning historical, meaning time is involved, and you have periods, and the period can be a month, a week, and so forth. Uppercase T will represent the number of periods in a season. We will talk about seasons, we'll talk about everything. So I will be repeating the same concepts over and over again. And whenever time is involved, whenever a time series is involved, it's a series of data that is time-based. We have components like random behavior. If we have a trend, and the trend can be upwards or downwards, we can have seasonal effects, we can have cyclical effects. A time series will be called stationary when it doesn't exhibit trend or seasonal or cyclical effects. Basically, it's random. And I want to show you what exactly a trend is. So let's click here. This is a hyperlink, and we will go to a spreadsheet that is used basically in the homework that relates to this topic, to forecasting. The PLE database, the PLE company, Performance Loan Equipment, is a company that does business in a number of regions, North America, South America, Europe, the Pacific Rim, and lately the last region that they got into to do business is China. and, and then we have another column that basically counts the total sales. Let me put commas here so we can read these numbers easier. Okay, it's a lot easier. Oops, and we have, I don't need the 2 digits of precision, so let me take that out. Okay, so it's a lot easier to read these numbers where they're greater than 1,000. So, so this means in January of 2014, there were 6,000 units, more units sold in North America, 200 units in South America, 720 units in Europe, 100 units in the Pacific, 0 units is China. In China, because in 2014, the PLE company has not opened up business in China. As you will see, as we move later on, they started to sell mowers in China in March of 2018. Okay. And this 7,020, this is the sum of the total sales all over the world. Okay, the most important thing, and I emphasize this in many of my lectures, in all of my lectures, is that when you have data, you want to ask the following questions. Who collected the data? Is there discrimination in collection of data? We are facing the virus COVID-19 right now, and everything has been politicized, and it should not be. The virus does not belong to any political party. The virus is not Democrat, it is not Republican, it is not independent. Data is data, but data manipulated makes it counterproductive to report on data that's collected improperly. So the important questions on data is who collects the data, under what conditions is the data collected, and does the data have integrity? So when we say 6,000 more units sold in January 2014 in North America, you know, is this number a correct number? All right. So, because you do not want to underreport or overreport, even though that happens in real life, and so you do not want to do that, because eventually somebody will lose their job, the company will lose the money, and so forth. So anyways, so here in this diagram, I have plotted a line graph, a scatter plot with the dots connected for more units in North America. So if I select the month in North America and click insert, and then recommended charts, recommended charts, you see that is the first one that's being recommended. Okay, and so we take it. Now, in this graph, let's observe. So this graph is for North America, okay, and let's paint the data yellow. Let's paint this area yellow so we know that this is North America, even though I have the heading. And these are decisions for North America. Okay. So this graph, if we look at it, and when you have a graph, by the way, that has, on the x-axis we have month. So this is time data. So this is a time series going up and down. It's a good idea to stretch it because you see better what is going on. Okay, but and so you see when you stretch it, you see the date, the date on the t line, on the x, on the horizontal line. Okay, so here we want to ask the following questions. Do we have seasonality? What is a season? If we look at this data, it starts in January. Okay, it starts in January. And if we define the season as 1 year, you see that it basically goes up and comes down. Then it goes up and comes down. So this is repeated, all right, almost the same. It doesn't have to be exactly the same, every 12 months. So our season, so we have seasonality. Our season is 12 months. So one season has 12 months or periods, all right? Do we have a trend? In order to have a trend, so this here is a time series. You see, the time series does not move up or down. It doesn't go upwards, or it doesn't go downwards. So there's no trend. And then I ask another question. Do we have, is the amplitude changing? So what is the amplitude? If you take the lower point and you take the, let me clean this up so that, so if you take the lower point and you take the higher point, this distance here is the amplitude. Okay, so that is the amplitude. Okay, and this basically is the same. Okay, it doesn't change much. So we have a stable amplitude. All right. So we talked about seasonality, we talked about trend, and we talked about the amplitude. So when you have this, if you look at these three, all right, we'll talk about the later on the forecasting technique. The forecasting technique that's used in this case is the Holt-Winters additive without trend, or we can use multiple regression. And so so these three tell us what forecasting technique or model we are to use. Okay. Now if I click this link here, click in another, so then click in this link, it takes you back to the concepts review spreadsheet. Let's go again back here. Okay, let's go to South America. Okay, South America is is another plot where we are plotting, and let me let me take the color off from month, because so the yellow means month plus yellow. South America, let's give it another color so it's easier to see what is going on. Let's give it the color light green. And we're going to color this light green as well. Okay, All right. So in South America, again, so this is South America, right? We notice that we have seasonality. All right. We see that the this guy right here repeats itself every year. All right. So we have that. We have seasonality. Now you see that this is not really horizontal. There's a slight trend. Okay, so there's a slight trend. There is a slight trend, but the amplitude, again, if you take this height, if you take this height right here, everywhere, this amplitude remains about the same. Okay, so this distance here, if we call this distance A, something like 3 inches, let's say, right? So the amplitude is stable. So in this case, we have hold winters additive without, no, this is when we have a yes and a yes. I think I was copying things. A yes to seasonality and a yes. This is, we can actually use hold winters additive with trend. So you have these two with trend. All right, oops. So you see that you can use the whole winters algorithm without trend and with trend. Okay, the formulas behind the scenes, there's a lot of formulas behind the scenes differ when you are doing whole winters additive without trend and whole winters additive with trend. Let's go to another one. Here in Europe, you have the same idea. Okay, you have seasonality, you have trend, the amplitude is about the same. Now you see here you have a trend, and because this sort of goes downwards. So the trend sort of goes downwards. Here the trend kind of goes upwards like that. Okay, so when the graph goes upwards or downwards, you have a trend. When it repeats itself, when it repeats itself, you have seasonality. And for us, the season will be 12 months, 12 periods, okay? All right. So I want you to get the idea of seasonality, trend, amplitude down. In here, in this graph for Pacific, and I can stretch this out more, all right, you see that you have trend. Okay, this graph goes upward. There's trend, but you do not have seasonality. If we look for from year to year, so if we look, this is January of 2014, January of 2015. You look every year. Okay, you really do not get the same behavior. Now somebody can say, well, it looks approximately the experience of the person in making the decision can override many things. But here you do not really see something, you know, this doesn't really look very, very close to that, and that, and that, and that. So, but I will say this: in all the cases, when you do prediction, when you do data mining, forecasting, the experience of the person involved, somebody can say that there is seasonality, when to the inexperienced eye, it may be that there is not. But anyways, for us, we will say no seasonality, yes to trend. And in this case, the forecasting algorithm or model is double exponential smoothing. How were this decided? This was decided based on mathematical econometric models. There's a lot of theory behind it, and there's a lot of formula behind it, and that is not, that doesn't concern us. All right, we will use some formulas, probably more than at any other time during this course, because we rely on Excel only. The best way to do forecasting is to really use software, but it's important to understand the underlying concepts. When I say software, I'm talking about software so that you do not really need to know the formulas. Here we have Excel, and we will try to do things with Excel by doing a little bit of coding, and I will challenge you to follow me along. So, all right. Let's clear this. Here we have a yes/no whole Windows entity without trend. You see here you do not have trend because this is if you look at this right here, you do not see things going, the graph going up or down. Okay, so you have kind of a stable environment as well, because the amplitude, and the amplitude is, if you take, I mean, you can go from here to here, to here, to here. If you do this, oops, if you do that, and then if you, the amplitude is this height right here. So you see that the amplitude is stable. So it's really this is the same height. So you have yes, no, and this is because you have no trend, whole Winters entity without trend. So you can also use multiple regression. Let's move down. Oop, that's all we had here. Okay. Okay. We will we will take a look at some others. Let's clear the drawings. Let's go back, click inside another cell, and then go to where it says go back to concepts review. I want to demonstrate also when we have some other types of models. So here you see you have a trend. If I look here, okay, if I look right here, and it goes it goes up. The whole graph kind of goes up. and so you have one trend from here to there. So you have, they break it in two parts. This is one trend, and this is another trend here, and there's another trend here. But overall, you have this trend. Overall, you have this trend here, then you have another trend over here, and then you have another trend going down over here. So you can have that scenario as well. Okay, So a seasonal effect is where things repeat. We talked about that, and we saw that so if I do this, and you see that the graph goes in January, it starts up, then in July it goes down, and it goes back up again. Okay, so this is one cycle, all right, a seasonal effect, a seasonal cycle, and then you have another one over here. So, all right, so you have season. This is a seasonal effect. All right, a cyclical effect is when, so a seasonal effect is usually, it can be, a season could be a week, usually it can be a month or a quarter, every 6 months or a year. But when you're looking for a cyclical effect, this can take 10 years, 5 years. So here you see how it basically, it starts in January of 1960, and it goes up, and the peak is in 1981, and then sort of it trends down. So you have a trend up for 11 years. What is this? 1960? No, from 60 for this. So this is a cyclical. This is 1960 to 1981, 21 years, and from here to here, another 21. So it's 2000. It's about here. So a cyclical effect is when you see this pattern repeat every 40 or 50 years. Okay. But it can be defined, because a cyclical effect can be every 5 years, for example, or every 10 years. It's when you see a pattern repeating over a much longer period of time. Now, this is how you can select the appropriate time series based forecasting techniques. And here we have this is no seasonality. This is seasonality when seasonality is yes. So seasonality no, seasonality yes. And this is no trend. Trend equals to no, and this is trend equals to yes. And let's do this, then do this and that. So if we have seasonality and no trend, then you can use the whole winter's additive. Oops. Then you can use the whole winter's additive model, no trend, okay, or multiple regression. If you have seasonality and trend, then you can use whole winter's additive, or in this case, you can also use whole winter's multiplicative. Okay, so and there are various combinations. Now, so we have the two factors. The two main factors are seasonality and trend. I also talk about the amplitude, but these are the two key ones. So you can have yes, 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 no. You can have no, yes, and no, no. So if you have yes, yes, then you're here. So this is the yes, yes. If you have yes, no, then you're here. If you have no, yes, no, and yes, no to seasonality, yes to trend, then you can pick a double exponential smoothing, for example. And if you have no, no, then you are right here and and then you can then you can either pick a simple moving average method or a simple exponential smoothing. Now, if you have a yes, yes, and here is the amplitude. If the amplitude is stable, then we use Hall Winters additive model. If you have let me erase these. If you have seasonality and trend, and the amplitude is increasing, okay, then we have Holt-Winters multiplicative model, right? So HWAM is Holt-Winters additive model, all right? And this is when seasonality equals yes, trend equals yes, and amplitude is stable. Okay. Then we can also have the Hall-Winters multiplicative model. So Holt-Winters multiplicative model, and this is season. Maybe I can just copy this from up here. No, oops. Okay. Okay. I messed this up. I should not have left. Seasonality equals yes, trend equals yes, and amplitude is increasing. Okay. So in that case, we have the multiplicative model, and we will see how it looks like when the amplitude is increasing. Oops. There you go. All right. All right. Now, let's clear the screen. And let me take you to a place where we have, I want to show you a picture of when the amplitude is increasing. And okay. Before I proceed, let's go back to concepts review. This is where we are, okay? Let me take you to the model menu, because this is what you will use in your assignment. The assignment in chapter 9, I break it down into 5 parts. The assignment is asking us to do forecasting for mower sales, for tractor unit sales. This is forecast for more unit sales. Okay. We need to do forecasting. Let's make this bigger. Okay, like that. So I divide the assignment. There's a tremendous amount of work in in the assignment that involves forecasting. And I divide it to 5 parts. Part 1 is forecasting more unit sales. And this is, I list the regions here. And I tell you that we will have seasonality, yes, for North America, trend, no. And this is the forecasting model to use. And if I don't talk about amplitude, then it means amplitude, it doesn't, is not increasing. So in green, it's, if everywhere you see green on this spreadsheet, green is whole winters additive model, okay? And with or without trend. In part 2, we do, again, we want to do forecasting for all 5 regions: North America, world, South America, Europe, Pacific, China. Don't ask me why I put world number 2. I just came up, it just happened. There's no rhyme or reason. Okay, so you see here, in world, in part 2, you have seasonality, you have trend, and the amplitude is increasing. So that is when we use the whole winters multiplicative. Okay. So yellow is double exponential, when we use the double exponential smoothing or regression. And because we've done regression, I'm not going to do regression here. So yellow is always double exponential smoothing in this spreadsheet. Okay, everywhere you see it. Okay. And green, everywhere you see green, it's whole winters additive model. So I want to illustrate each one with one example, each one of the various forecasting models. Okay. So where is my multiplicative? The multiplicative is with forecasting tractor unit sales for North America and for the world. So let me go to forecast tractor unit sales. Okay. So this graph right here is, let me make everything bigger on this page. Let me first put borders everywhere. Let me make everything size 16. And even this, so we can see things better. All right. This is okay. So here, and you can stretch this out. This is the graph of North America. Oops. Let me move this a little bit to the right. Okay. Okay, because I want to stretch the graph a little bit more. So this is, if I move to the left, plotting the month and North America. All right, so if I make this green, then the columns used were these two. Okay, so now let's see why what we have here. Okay, we have if we look at the season. Let me go to my pen here. So the season goes from January to January. So this here, so we have a season from January to January, right? So it sort of goes up and down, up and down, up and down. It goes up and down, but now you also, so it's seasonal, okay? So it is seasonal, all right? It is seasonal. Then you also see that it goes, you have a trend, all right? So seasonal, and we have a trend. Seasonal equals yes. Seasonality equals yes. Trend equals yes. And the amplitude is increasing. All of these say that the forecasting technique to use is a whole winter's multiplicative model. Okay, that's the model to use. Now, if I am going to look at the amplitude, I want to draw this. Let's clear this picture. So here you have, so the amplitude between this valley and this peak is this height. Okay. Then you take this valley and this peak, and the amplitude is this height. Right? Then you take this valley and this peak, and here is the amplitude. So you see the amplitude increases. This amplitude, just to be clear, so let's call this amplitude. Okay, so let's call this amplitude 1. This is amplitude 2, which is almost the same as amplitude 1. But then you see amplitude 3, this height right here. Okay, it is definitely true that amplitude 3 is greater than amplitude 2. And then you have this guy here, which is amplitude 4. So you see, you have this idea, amplitude 1 is less than or equal to amplitude 2, which is less than amplitude 3, which is less than amplitude 4. So as you move from left to right, the amplitude picture, the amplitude increases. So here the model is whole winters multiplicative. And this is this was part 2. Okay, this was in part 2, tractor unit sales for North America. Tractor unit sales for North America. Okay. So if you at all times you can go to model menu, and this tells you the combinations of of seasonality and trend. And where I say other comments, this should really be amplitude here. So this should be amplitude. And if I don't say anything, it means it's stable, okay, or it doesn't apply. So all right, there you go. Okay. So as you see, I divide the work in 5 parts. Part 1 is forecasting more unit sales. Part 2 is forecasting tractor unit sales. Part 3 is forecasting industry more sales. Part 4 is forecasting industry tractor sales. And part 5 is forecasting production costs. This here, when I say forecasting more unit sales, this is for PLE. For PLE only. When I say forecasting industry more sales, this is for the whole industry. Okay, so you have more unit sales here in part 1. You have more sales in part 3. In part 1, you have unit sales at PLE. In part 3, you have unit sales in the whole industry. Part 2 is forecast tractor unit sales at PLE only, for PLE. And part 4 is forecasting oops, is forecasting so parts 2 and 4, okay, all right, but part 4, this used to be a link, that's why it thinks, okay, I need to remove the hyperlink here. Okay. So parts 2 and 4 have to do with tractor unit sales. Part 2 is for sales by PLE, and part 4 is sales in the whole industry. Okay, and in part 5 we have to do with forecasting production costs. And here I give you the combination of how do we decide the forecasting model to use. And basically I use seasonality, trend, and if we have amplitude or not. If I say nothing underneath amplitude, that means the amplitude is not increasing or decreasing. The only times I put something underneath the amplitude column is if the amplitude increases. Okay. All right. So let's go back to concepts review. Okay. Now I want in this recording to start by talking about the simpler versions of forecasting, the simple forecasting models. So I want to talk about the moving average model and the exponential smoothing model. And I want to keep my recordings to about an hour. So if I get close to an hour, I will stop it and then continue on the next recording. So let's talk about the moving average model, the moving average forecasting technique. The best way to figure out and to understand what is going on is, see, if I will read this statement, but if you don't know what that is, you say, huh? So let's read it anyways. The simple moving average method is a smoothing method based on the idea of averaging random fluctuations in the time series to identify the underlying direction in which the time series is changing. The simple moving average forecast for the next period is computed as the average of the most recent K observations. and larger values of k result in, the larger the k is, the smoother the forecasting model is. Because the values that are far away have the less impact. Well, what does this all mean? You see, again, let's call this a circle here. It looks like an egg. It's not a circle, but I call it a circle. So here you see, you say the hand. That means if I click on it, I'm going to go to another spreadsheet. Okay. So here, I want to demonstrate using the moving average with with couple of different values of of k. In this situation, when we do not have seasonality and we do not have trend, so that's a no. All right, and in this case, no and no. So if I go back, if I go back to, I have another picture here, forecasting models. This is the latest combination. So if the seasonality is no and the trend is no, then, and this is where we are right now, and to illustrate where we are, let us do this. Oops, that covers the thing. We don't want this. Let's use this. So I want to, no, okay. So this is where we are, and I want to show you the simple moving average first. Okay, the simple moving average first. All right. And so let us go to let us go back to concepts review. Concepts review is where I do everything from. So you can go there, and from there you can, all right, that's why this is like the docking. This is the dock, this is the station, this is the main menu. I click here, and this is where this is where I am. And we gotta get rid of this guy. We always have to do cleanup. And okay, there you are. So I actually don't need this. This is simply the data that we have here. The data that we have here, right here, is the actual sales of tablet computers. In week 1, we had 88 tablets sold. Week 2, 44. Week 3, 60. So I have the sales, the actual sales for the next 17 weeks. And if I select these two and click insert and recommended charts, then the first chart that I get, if I click OK, then I get this chart right here. Okay. So I get this chart. So this simply is a line chart of the actual sales. If we look at this, you see that you have some randomness here. This graph doesn't really go up, or it doesn't go down. The best way to do it is to see if it goes up and down. Just I mean, if the whole graph moves in an upward direction, you see, if I okay, if the graph was, the whole graph was moving in that direction, then you would have trend, or it could be moving in that direction, the whole graph, the whole thing, and it's not. So we do not have a trend. Okay. Do you have a season? So if you go here we're doing weekly things on a weekly basis, so you don't see anything really special going on. So if you even if you stretch this out, as you go from, this is a 2-week period, right? You don't see, if let's say you define your season to be two weeks, right? So you don't see a pattern for every 2-week period. So we don't really have a season. We do not have a trend. We do not have um, the amplitude goes all over the map. So if you look at seasonality and trend, they're both no. Okay, if you look at those two, they're both no. So no and no. If you go to forecasting models, no and no, it says you can use the simple moving average or simple exponential smoothing. Let's look at simple moving average. And again, I'm going to go to concepts review and click. Okay, so the graph of the actual data helps us identify the seasonalities, the trend, if there's amplitude going up or down, or if the amplitude is stable, and then the forecasting model. Okay, now so let me remove this graph from here, and I am going to, there are different ways. Oh, I can go back and forth to the concepts by clicking this. I forgot. All right, so you can, okay, there you go. That's why I put this over here. So I'm going to do this forecasting. We can do it manually. And by the way, there's variations of what I'm going to do, but I'm going to do create this forecast model, these forecast values when k equals to 3, and the forecast values when k equals to 4. So so here k equals to 3, right? Now, the way that Excel does it, let me remove this from here. All right, and I want to show you the idea. Now k is 3, right? So okay, so click. I'm going to show you how to do simple moving average with k equal to 3 and k equal to 4 using Excel. So click data, and then go to data analysis tool pack, and here is the moving average. Double click there. I cannot make this bigger. So this is input range. Okay, so my input range is I'm going to select actual, the heading actual, and the actual data. I included the label, the interval, because k equals to 3. I'm going to put 3 here. The output range, click over here. All right, the output range or where I want the output to appear, I'm going to click the up arrow, and I want my output to appear over here, starting over here. I will not check the chart output and the standard errors and click OK. Okay, so let me make the size of this 16, bold face it, and if I select this, whenever you see that little green triangle in the upper left corner, it's just a warning message of some sort. It's not really an error. Click this and say ignore error to get rid of this. And I'm going to select all these values, and I'm going to go to number and make it number with simply 2 digits of precision. That way it doesn't look ugly. And it says pound NA and pound NA. Okay, why does it say that? What is going on here? Okay, let me put the cell borders. All right, let me grab these. Let me grab these in my snipping tool. I'm going to grab these right here. All right. Remember, K was 3, right? And let me put this in Paint because I have nicer tools over there. Oops. Put it in the middle of the page. Okay. So K is 3. So okay, what is going on? All right. So you see this 64 here with K equal to 3. All right. Each of these values, let's call this, so this is week 3, right? So this is the forecast in week 3. This value, the forecast in week 3. So this is going to be called actual 1. This is actual 2. This is actual 3, actual 4, actual 5. So this is forecast 1, which really we don't have it, right? This is forecast 2. This is forecast 3. This is forecast 4, forecast 5, forecast 6. Let's just do a few of these. A1, 2, 3. Oh, here is forecast 4. Okay. I messed up. So let me take these guys out of here. This is a forecast 5. This is forecast 6, and so forth. Okay. Now remember case 3, right? So that means f of 3 will be equal to the last 3 actuals, but it will be A3 plus A2 plus A1 over 3. And this is equal to, so it's the average of these 3 values, right? So if you take 60 plus 44 plus 88 over 3, 60 plus 44 is 104, so this is 192. And if you divide that by 3, then that gives you the 64. So that's how you get this. F4 will be A4 plus A3 plus A2 over 3, right? So it's going to be so, oh, okay. No, it's, have a different eraser here. No, this is, I keep forgetting, I'm going through so many tools, but I can go back to Excel actually, and you see, if I double click here, 64, it highlights the 3 latest numbers, 60, 44, and 88. So this is the average of B4 through B6. It's the average of 60 plus 44 plus 88. Okay, press escape, go to 53 and double click in it. So this highlights the, so to get, so this was F3. Here we have F4. okay? Which means so F4 is the last three, including the current actuals, the average of those three. To find F5, let me change the color. Let me make it blue. To find F5, F5 is the average of these three, all right? Let me pick another color. You should be getting the idea by now. Let's pick yellow. Here is, that's not such a good color. Black. So this would be F6, F6, F6 right here, right? F6, the 6 goes with the week, right? So this is the average of these three values. So this is how you find, this is called simple moving average, because this average is moving, right? It changes. Each one of them has three different values. and then um, I can plot the actuals and the forecasted values. So then what I can do, let me clear this up. Let me delete this whole thing. If I take these three columns, okay, these three columns, and I say insert recommended charge, then you see, okay, this is the line graph, and then you see the actuals together with the forecast. This you can give this a name. You can change the chart title. You can also click in this area, click the plus sign, and say axis titles, and then go to the axis titles and click inside it, label the axis. So this is the x-axis is the week. Oops, week. The y-axis is tablet computer sales. Okay, I need to clean this up first. Okay, so this is tablet computer sales. And you can make the font size big. Oops. All right, big, bold it, do whatever you want, color it. All right, the same thing with the horizontal axis. If I see a graph without any labels in the assignment, I'm going to take 5 points off. Okay, why? Because you never present any graph without proper label. So up here, the chart title, and I want meaningful labels. So this is tablet computer sales. And you can, let's say if this was Amazon tablet computer sales. All right. So in this graph right here for k equals to 3, we see that let me go get my stylus. You see that the blue is the actual, right? The blue is the actual, and the brown is the forecast. We did not have data for weeks 1 and 2, because in order to find, remember k is 3, right? In order to use 3 values, see this 64, it needed 3 values. If I was trying to find forecast of 2, right, and I would need to go to this and then get the last, so I need to have one more number, and I don't have it. That's why this here is not calculatable, and also this is not calculatable. All right, so you start here. So that means for weeks 1 and 2, we do not have forecasted data. And so you see the blue and the brown, And in some instances, the forecast is less than the actual. So here you're under forecasting. In other instances, the forecast is higher than the actual. So this is your over forecasting. And this difference right here is the error. And this is the same thing with the COVID-19. COVID-19, all right? A model can predict this number of infections, and then when we get the actual figures can be higher, or a model can be a high number and the actual can be a lower number. Okay, so to then do to do the same thing, but to do forecasting with k equals to 4, we go data analysis toolpack, moving average. Again, the data, the input range is just the actuals. Now, if I say interval equal to 4, the output range is always up here. So I'm going to make the output range D4, okay, D4. Now, I can, let me delete this graph because I want to show you how this graph can be actually generated. So go to click data analysis, moving average. Okay, make sure that in the input range you have the actual correct actual data, one column. I do not select the weeks here. The interval is 4, all right, and the output range is D4, and I'm going to pick chart output and then click OK. All right, so this generates both the forecasts and the proper chart. I am changing everything to be of size 16 so we can see easier what's going on. Okay, so I see here you have again the actuals and the forecasts. And okay, and once again we have these silly errors. So select everything, click this, say ignore error. And I want to make everything to have 2 digits of precision. Select this, go to number, and click number, 2 digits of precision, click that. Okay, so it looks nice and uniform. So now what you see here, now K is 4 here, right? So K is 4, and so this is F4, all right, 62. This 62 is the average of the last 4 actuals, including the current one. So 62 is the average, right? Is the average of 88. So F4 is A4 plus A3 plus A2 plus A1 over 4. So it's 56 plus 60 plus 44 plus 88. If you go here, F8, right? This is going to be the average of these 4. If I want to see how this was calculated, F17, right? Then this would be the average of these 4. So you see, with this method, if I wanted to find F18 with this way to calculate simple average, I cannot do it because I have nothing here. There's a variation of this that allows you to do that. But this is the simple moving average. Okay, and right here, and I click go back to concept review, and here we will have the end of the first recording. We will continue with actually right here. This, by the way, show you what I showed you is how Excel does a simple moving average. These slides show you a slightly different one, but what about the one that I showed you? Okay, we will stop right here. So this is the end of recording 1. Okay, end of recording 1. End of forecasting recording 1, and make this big, bold-faced. We will continue with metrics and forecast accuracy in forecasting recording 2. Thank you very much, and I will see you on the next recording.